All right, so let's look at section 9.3, forward chaining. Hopefully this is going to be pretty brief. It's not too long. This is just going to be a way for you to draw inferences from your knowledge base. Okay, so this is a way of doing it. We looked at how to do this with propositional logic, so now it's time to look at it for first order logic. All right, so big idea. You're going to start this process with atomic sentences in your knowledge base, and then you just continuously use modus ponens over and over and over again in the quote forward direction, right? So you start off with some atomic sentences, and then you just keep using those as part of modus ponens, and you're adding new atomic sentences that are the result of modus ponens, in a cycle, in a loop. Okay, and so when there are no more possible inferences for you to make, then you're done, right? You're done with your chain. Okay, you're done with this repetition. And so this is very, very useful for systems that will use this type of functionality. You detect some kind of situation, and that's going to apply or imply that you should do something in response. That there should be some kind of logic that your system responds with. Okay, and this can be done very efficiently, and the textbook goes into a discussion on how to improve it in terms of efficiency. We're going to look at a very basic algorithm just so we can understand how the chaining works in general. Okay, so let's take a look at first order definite clauses, and we need to do that because in order for this chaining algorithm that we're going to use to understand how forward chaining works in first order logic, the knowledge base has to be built of all definite clauses, all definite first order clauses. Okay, so the definite clauses in first order logic, they're very similar to the definite clauses in propositional logic. They're going to contain disjunctions of literals, where exactly one of them is positive, and that's going to be an important restriction, which we'll talk about here again in a second. And the definite clauses themselves are going to be either atomic or a particular type of implication. So here's some examples of definite clauses in first order logic, right? So you got, anything that is a king and greedy that implies it's going to be evil, right? This is a definite clause in first order logic. John is a king. That's another example. Something is greedy, or all people are greedy, is another example of a definite clause in first order logic. And the implication here, the antecedent part, right, this is the specific type of implication. It's going to have a conjunction of positive literals, and the consequence has to be a single positive literal. Okay, so those are two restrictions. Right? A restriction on how the implication is built, and the fact that you've got disjunctions of literals where only one of them is going to be positive. Okay, now first order literals, as I was saying, they can have variables, and they're always considered universally quantified. Now, because of those restrictions we just talked about, not all knowledge bases could be converted into a knowledge base that contains only definite clauses. But if you can, then you can easily apply this forward chaining algorithm that we're going to examine. So let's take a look at an example from the textbook on this. And so they wanted to be able to prove or be able to show by implication through the process of forward chaining that this guy named Colonel West is a criminal. So here's some knowledge that we have that we're going to encode in first order logic using definite clauses into a knowledge base on which we can apply forward chaining, a forward chaining algorithm, to demonstrate that West is a criminal. So what is the knowledge? What are we trying to? What's the knowledge that we're going to have to encode in the knowledge base? So here it is. The law says that it is a crime for an American to sell weapons to hostile nations. The country of no-no is an enemy of America and has some missiles, and all of its missiles were sold to it by Colonel West, who is an American. So we want to prove that West is a criminal. So the first thing we have to do is we have to put together our knowledge base. All right, we have to represent the facts in our knowledge base using first order logic. Right? So, first fact, it's a crime for an American to sell weapons to hostile nations. So here is a first order logic clause that we could use to represent that. So remember, this thing is by default considered universally quantified. For all x, if x is an American, and for all y, if y is a weapon, and for all z, if z is hostile, and that x sells that thing to z, and if that x is American and that thing y is a weapon and that z is hostile, then that implies that that x who did the selling is a criminal. Right? So we can say that no has some missiles. We can represent that with an existentially quantified sentence. There is something, there exists something in the universe that no owns, and that something is a missile. And we can change that sentence into a definite clause by existential instantiation. We'll give a name, right? Rather than having a variable, we'll give it a name. So we'll say, that we have this fact that no owns this thing called m sub 1, and with this separate fact, we're saying that m sub 1 is a missile. All of Nono's missiles were sold to it by Colonel West, so let's go ahead and convert that or represent that as a first order definite clause. X is a missile, Nono owns that thing. If X is a missile and Nono owns X, right, that implies that West sold that thing, X, to Nono. All of its missiles were sold to it by Colonel West. Here we're going to encode that missiles are weapons. For all things X, if it is a missile, then that X is a weapon. Here we're encoding the fact that an enemy of America is considered hostile. So for all things X, if it's an enemy of America, then that X is hostile. Then we're going to encode the fact that West is an American. So we'll have that definite clause, American West. And then we'll go ahead and encode the country Nono as an enemy of America. Right? Nono, enemy, America. Alright, so all of those sentences that we just went through, and all these clauses, these are definite clauses for our first order logic knowledge base. And none of them were function symbols. We didn't need any function symbols for this knowledge base. So that fact, that reality, means that this knowledge base is a particular type of knowledge base, and that knowledge base is referred to as a data log knowledge base. Now a data log, what is that? It's a type of language. Now here's the definition. It's a type of language restricted to first order definite, that should say definite, not definitive, clauses with no functions. So what does that do for us? Well, that makes the inference is a lot easier, right? The inference is easier if you don't have any functions. So didn't want to include and make the inference easier. All right, so what do we need to do next? Now that we have a knowledge base, it's a data log knowledge base, we can do easier inference on it. We need to go through the algorithm for proving that West is a criminal. All right, so now that we have ourselves a knowledge base full of first order definite clauses, let's look at a simple forward chaining algorithm to do some inference for us, right? So here's the idea, which I talked a little bit about at the very beginning, right, of the section, but of the video. So start with known facts. We're going to trigger all those rules whose premises are satisfied, and so the rules are the implications, right? The implication definite clauses. The premises are satisfied if the pieces of the conjunctions are true, and then if they are, then the conclusion of that implication of that rule is going to get listed to, or it's going to get added to our list of known facts. And so you just keep on going. You just keep repeating this process over and over again until you come up with a rule that is the thing that you're trying to prove, until your query is answered, or until you can't generate any new facts, right? If there's no new facts for you to generate, that means that you've run through your chain of logic and you never reached the conclusion that you were looking for, right? You were trying to see if A led to B, and then if B led to C, and then if C led to D, to get you to F, right? Now, if you can't generate F, you can't say that F was true, right? Or that F was implied. But if you can generate F, then you can say, well, yeah, it's implied. We just proved it. We just proved that, Colonel West is a criminal if F was Colonel West is a criminal, if that's what we wanted to prove. All right, so just a couple little tidbits here to keep in mind before we start digging in. Facts themselves, they're not going to be new if all you've done is, renamed an existing fact, right? So what's renaming? A sentence is a renaming of another if they are the same except for the names of their variables. So example, likes X ice cream and likes Y ice cream. This is saying the same thing, right? So you wouldn't be adding, if you already had likes X ice cream in there, where you're saying, well, everybody likes ice cream. If you added a new sentence, likes Y ice cream, that's not a new fact, right? That's not something new. You're saying the same thing. You're just using a different variable name. They have the same meaning. So you wouldn't be adding, another sentence that has the same meaning as something that exists. The only difference there is that you have a different variable name. All right, so here's all the definite clauses of our knowledge base all in one place. So let's go through and see an example of the chaining playing out. So in order to prove that West is a criminal, we're going to need a couple of repetitions for this to work out, right? So what are our rules, right? The rules are all the implications, right? Rules equals implications. Okay, so what are they in this knowledge base? 9.3, 9.6, 9.7, and 9.8. So what are the facts? Okay, the facts are all the others. Facts are entries in the knowledge base that aren't rules. So 9.4 is a fact, 9.5 is a fact, 9.9, and 9.10. Right, so remember how this works. Continuously try to satisfy the different rules, premises for the different rules, and that allows you to add their conclusions to your knowledge base. And you just keep going until you can't add any more new facts and their conclusions to your knowledge base. Or until you find the thing, or until you generate the thing that you're trying to prove. In this case, what we're trying to do is we're trying to prove criminal West. So we have to generate that sentence in order for us to be able to infer that West is a criminal. All right. So let's start doing it, right? So what can we satisfy here? Well, let's look at 9.6. Okay, we're gonna have to go through these other three rules before we can do 9.3. We'll have to do the other three before we can satisfy 9.3. Anyway, so 9.6, missile X owns no X. Now, is there any existing fact that we can plug in for that implication, right? For the premises for that implication? Well, yeah. Look at missile M1, right? So missile M1, we could substitute for missile X here, and then that would create missile M1, right? And for owns no X, we could replace that with 9.4. So then that would be M1, okay? So that would satisfy the premise for that rule, 9.6, right? And so then we could fill in for West, or excuse me, for X, the M1, because remember that's the variable that's missing for all three of them. Right? So M1, no, no. Okay, so since that premise was satisfied, we can add the conclusion as a fact to our knowledge base. So let's do that. Okay, so new fact. Cells west M1, no, no. Now, can we satisfy Rule 9.7? Well, let's look at the knowledge base. There's an existing fact 9.5 that would satisfy that implication right there if we replace the x with the M1. So since that's satisfied, we can then add the weapon X to our knowledge base, where we've replaced the X with M1, right? Because missile M1 satisfies the premise here, and M1 was our substitution for X. Therefore, we have to have unification, right? By having our X replaced with the M1 there, so we can add weapon M1 to our knowledge base. Fine. Now we have to try to satisfy the premise for Rule 9.8. Well, how can we do that? Is there an established fact that we can use, that we can substitute for this premise? Right? Well, we've got 9.10. 9.10 would satisfy that. 9.10, because enemy, no, no, America. And so the no, no would take the place of the X, and since the premise is satisfied, then we can add the conclusion hostile X, where we replace the X with no, no. So we can say hostile, no, no. So, what was the unifier for, for 9.7? Right? Let's put this in here for X. What did we do? M1, right? What about for 9.8? Right? What was the X that we used? No, no, right? What about for 9.6? Well, 9.6 was also, the replacement for X was also M1. Now that we have added these three new facts to our knowledge base, we can then go back and satisfy Rule 9.3. Right? Now, how can we do that? Well, let's look for existing facts. Is there something here we can use for X? Right? What can we use for X? Well, let's look for a fact. We'll look at fact 9.9, American West. So for X, we can replace that with West. Right? Now, what about for Z? What can we do for Z? Or, well, let's go back over here to weapon Y first. Let me go in order. So weapon Y, is there anything that we can replace that's equivalent? Let's go down here. Oh, right here. Weapon M1. So we can replace that. They're equivalent. So for Y, we can do M1. Okay. Now let me do the hostile Z. Now, is there any fact in here that can satisfy this? Well, let's see. Oh, hostile, no, no. So, if we replace Z with no, no, right, then that will satisfy everything, because American X becomes American West, and weapon Y becomes weapon M1. Cells XYZ becomes cells West M1 to no, no. And then hostile Z becomes hostile, no, no. So since that entire thing is satisfied, let me just rewrite it down here so you can see it. American, okay, what's the substitution for X? West. And weapon, what was the substitution for Y? M1. Right. And hostile, what's the substitution for Z? No, no. No, no. And we had cells. Substitution for x was west. Substitution for y was M1. And the substitution for z was no, no. So what does that imply? Well, criminal. What was the substitution or the binding for x? West. Right? So since we satisfied the premise, we can add the conclusion to the database. What's the conclusion? That West is a criminal. Therefore, through forward chaining, we just proved, using our first order definite clause knowledge base, that Colonel West is a criminal. All right, so we'll just finish off the video. I walked you through how the algorithm works. I'll just finish off the video by showing you what the proof tree looks like from the text, and then showing you the algorithm from the text, and just highlighting the features. And I will definitely let you trace to this one on your own, because I showed you how it worked with the whiteboard, and so then I'll point you out the major pieces of it, and then, like I said, definitely let you trace this one out on your own to save time. But anyway, so here's the resulting proof tree, right? So these are all of our facts that already existed, right? And so we were able to then, the bottom level is the official facts. All of the facts that we were able to infer, they are on that first iteration, through our our bindings, for replacing x with m1, replacing z with no, etc. Those are on the second level here, right? So the m1 was derived from missile m1. The no here was derived, and the m1 were derived from no and m1 here. Because if it's a missile and it's owned by no, it must have been sold by West to no. Enemy, no-no's an enemy of America, so that's how we were able to plug the no into hostile. We were given that American was a West. So combine all three of these facts, right? All of these things together shows that all four of these pieces, that those were the pieces that were part of the one of the original sentences here that we had in our knowledge base, right? This guy right here. See all four pieces? American, and weapon, and cells, and hostile implies criminal X. So all four of these have to be true to imply that we have a criminal. So go back to the proof tree here, and you got American and West, weapon M1, and cells West, that M1 to a no, and no-no's hostile. Then therefore that infers that the conclusion that we can draw is that West is a criminal. All right, so there's no new inferences that can be drawn. Why not? Every possible sentence that we could have created is in the knowledge base now, and once you have a knowledge base that's in that state, that's referred to as a fixed point within the inference process. And so then finally, here's the first order logic forward chaining ask algorithm, right? So what does this do? Returns a substitution or false. You pass to it a knowledge base and a query, which is an atomic sentence. What was the query here? We wanted to know if West was a criminal. And what was the knowledge base? Well, that group of definite clauses that I showed you. So we have nested loops going on here, and I'll just point out those major pieces, and then I'll leave it at that, right? So we had, for each rule we went through, and we had to make sure that we standardized our variables. Now, what does that mean? What does the function standardized variables do? Replace all variables in its arguments with new ones that have not been used before. Okay, so we did that, and then we had to go through and look at all the different substitutions, right? And then we had to do that unification process. Remember, I mentioned that, the unification, the binding of the variables with data, with literals, so that way we could, do our substitutions, do the matching, and then finally we continuously added those new facts to the database until we couldn't anymore. Okay, so try to follow the pseudocode. Come up with your own example knowledge base, or just try to go through the one that the text used, right? And see if you can follow along and make sense of it, and maybe compare it side by side with the algorithm. Put your algorithm on one piece of paper to your left, and then on another piece of paper draw out the knowledge base and the rules, and then kind of go through what I did with the whiteboard. I was just following this algorithm right here. Okay. All right, yeah, so anyway, that's forward chaining. We got one more video to go in Chapter 9, and that will conclude the required content that we're going to be able to get to in the semester, and that's going to be backwards chaining, which is just this process in reverse, really. And so that one will be pretty quick, too, and I'll just give you an example of how that plays out. And then I'm hoping for the last week, I think it's Chapter 18, if I recall correctly, section 2 or 3. I'll have to go back and look. I'm trying to remember off the top of my head. There's a brief discussion of neural networks, and so I want to provide that to you. You won't be required because I'll have it for you basically during finals week, and so I'm not going to be able to give you any assignments on it or anything like that. We won't really have time to dig into it, so I won't require it on the test, on the final exam, or anything like that. But I'll throw it in because it does. The course description does mention neural networks, and so we can at least get a little flavor for it. There's a lot of math in that. We're not going to have time to build the math and the probability and all that, so we'll just get an overview of how they work, and that'll give you a jumping off point if you want to dig deeper into it on your own. Okay, and so you'll be working on Chapter 9 next week, and then the week after that is going to be finals week, and I'll have a study guide for you while you're working on Chapter 9. Okay, and backwards chaining, and then we'll talk a little bit about logic programming. That's right, I almost forgot about that. We'll also talk a little bit about backwards programming, or logic programming, along with backwards chaining in the next video, and then you'll start to see, the prologue really coming into focus, because the textbook has prologue statements and shows you how implications in facts are written. These first order definite clauses are written in prologue, right? And then the prologue interpreter is going to run the inference engine using algorithms that we're going to talk that we've covered. Specifically, it uses backwards chaining, but we'll talk about that next time. And it'll do that for you. It'll do that backwards chaining work for you. And then for your expert system, you'll have your facts, you'll have your rules, and then you'll be able to run the query to answer certain questions that you're asking or that you're posing to your expert system. So anyway, that's it. I'll shut up now. We'll see you in the next video.